At the bottom of the world, where temperatures fall far below freezing and winds carve through endless ice, something surprising is quietly happening every year. The South Pole is being moved. Not physically dragged across the ice sheet like a marker on a map, but scientifically redefined and relocated with remarkable precision. And the reason for this is far more fascinating than it first appears. The South Pole is not just a symbolic point on Earth. It is a carefully maintained scientific reference point used in geography, astronomy, and climate research. However, unlike the North Pole, which floats in the Arctic Ocean and shifts naturally due to drifting sea ice, the South Pole sits on the massive, slowly moving Antarctic ice sheet. This ice is not static. It flows, compresses, and shifts under its own weight, like a frozen river moving at a pace too slow for the human eye to notice. Because of this constant movement, the exact position of the geographic South Pole changes slightly every year. Scientists at research stations in Antarctica measure this shift with extreme precision using satellites, GPS systems, and geodetic instruments. What they find is that the ice beneath the South Pole is drifting by several meters annually. That may not sound like much, but in the world of high-precision science, even a few centimeters matter. The South Pole is not completely fixed, it shifts slightly every year due to the movement of the Antarctic ice sheet beneath it. The South Pole is often imagined as a perfectly fixed point at the bottom of the Earth, marked permanently on maps and frozen in place forever. However, in reality, it is not completely stationary. One of the main reasons for this is the nature of the Antarctic ice sheet on which it rests. Unlike solid bedrock that remains stable over long periods, the ice beneath the South Pole is constantly in slow motion. This movement is extremely gradual, almost impossible to notice in daily life, but over time, it becomes scientifically significant. The ice behaves somewhat like a very thick, frozen river, flowing outward under its own weight from the center of the continent toward the surrounding oceans. Because the South Pole marker is placed on this shifting surface, its exact position changes slightly each year. Even though the change may only be a few meters annually, it is enough to matter for precise scientific measurements. Scientists carefully monitor this movement using advanced satellite systems and GPS technology to determine the updated position. This ensures that when researchers refer to the South Pole, they are talking about the most accurate and current location, rather than an outdated one. Over time, these small shifts accumulate, making regular adjustments necessary to maintain scientific precision and consistency in global studies. Ice in Antarctica is constantly moving, the massive ice sheet flows very slowly, like a frozen river, causing gradual displacement. 2. Understand why the South Pole is adjusted. It is important to realize that Earth is not a completely rigid or unchanging sphere. The planet is constantly in motion, not only in its orbit around the Sun, but also in the way its surface and internal mass are distributed. One major factor is polar motion, which refers to the slight wobbling of Earth's rotational axis. This wobble happens because mass on Earth is always shifting. Glaciers melt, ocean currents move, winds circulate, and even large earthquakes can redistribute weight across the planet. These changes may seem small, but they are enough to affect the exact position of the poles over time. In addition to this, the Antarctic ice sheet itself is not stable. It slowly flows outward from the center due to gravity, causing the surface beneath the South Pole to drift. When these two effects combine, the geographic South Pole does not remain in a single fixed location. Instead, it shifts gradually, requiring scientists to regularly update its official coordinates. Using highly precise tools like GPS satellites and geodetic measurements, researchers track these changes and redefine the pole's position so that global scientific data remains accurate. Without these adjustments, long-term measurements in climate science, navigation, and astronomy would slowly lose precision and reliability. Scientists measure the shift using precise technology, GPS, satellites, and geodetic instruments, track changes down to centimeters. 2. Maintain scientific accuracy. The South Pole is not treated as a permanently fixed point, but as a carefully updated reference location. This is because modern science depends heavily on precision, especially in fields like climate research, astronomy, and global positioning system. Even a small shift in location can create long-term errors in data collection if it is not corrected over time. At the South Pole, researchers rely on extremely advanced instruments, such as satellite-based GPS systems and geodetic monitoring tools to track its exact position. These tools can detect movements of just a few centimeters, allowing scientists to observe how the ice beneath the station is slowly drifting. Because the Antarctic ice sheet is constantly moving outward from the center of the continent, the marker that represents the South Pole gradually becomes misaligned with its true geographic position. To solve this, scientists periodically relocate the ceremonial South Pole marker, so it matches the updated coordinates determined through measurements. This adjustment ensures that experiments conducted at the South Pole remain consistent from year to year. It also helps maintain the accuracy of global data sets that depend on stable reference points. Without this careful updating process, even minor shifts could accumulate into significant inaccuracies in scientific records over decades. The South Pole is regularly redefined for accuracy, minus its official position is updated so scientific research stays consistent and reliable. Another important reason the South Pole is adjusted regularly is because of how sensitive modern scientific systems are to location accuracy. Today, technologies like satellite navigation, space observation, and global climate monitoring depend on exact geographic reference points. The South Pole serves as one of these critical reference markers, so even a small shift can influence calculations used worldwide. As Antarctica's ice sheet slowly moves, it causes the physical position of the marker to drift away from the true geographic pole. This drift is not sudden but continuous, happening year after year in a steady motion. Scientists track this movement using highly advanced geospatial tools that compare satellite data with ground-based measurements. When they detect that the marker has moved too far from the calculated true pole, they adjust its position to bring it back in alignment. This process is not just symbolic. It ensures that scientific experiments conducted at the South Pole remain comparable over long periods. Without these adjustments, data collected decades apart would not match properly, leading to errors in understanding climate trends and Earth's behavior. By keeping the South Pole precisely updated, scientists preserve the integrity of long-term research and ensure that global scientific systems remain reliable, consistent, and universally standardized across different fields of study. Earth itself is dynamic minus polar motion, and changes in mass distribution, like melting ice and ocean movement, also contribute to shifting pole positions. The shifting of the South Pole is also closely connected to broader changes happening across the entire Earth system. Our planet is constantly redistributing mass in many ways, and these shifts subtly influence the position of the poles over time. One major factor is the melting of polar ice due to climate change. As large ice sheets lose mass and transfer water into the oceans, the balance of weight on Earth's surface changes. This can slightly alter the way the planet rotates and how its axis behaves. Ocean currents also play a role, as massive volumes of water are continuously moving across the globe, carrying heat and energy that affect Earth's physical equilibrium. Even the atmosphere contributes, as large-scale wind patterns shift pressure systems that add or remove force from different parts of the planet. These combined effects create a dynamic system where nothing remains completely fixed, including the South Pole. Scientists study all these interactions carefully to understand how Earth behaves as a whole system rather than separate parts. By monitoring these changes with satellites and precise measurement tools, they can track how the pole shifts and adjust its official position when needed. This ensures that scientific models remain accurate and reflect the true, constantly changing nature of our planet.